Hi guys, this is two lessons today, 8.1 and 8.2. So we're going to combine the titles and we are going to call this adding, subtracting, and multiplying polynomials. Let's start by just talking about some words. If I say monomial, I'm talking about something like, for example, 5x. 5 times x doesn't have any adding or subtracting in it, and so this particular cluster of things together being multiplied together is called a monomial. Let's talk about a binomial. An example of a binomial would be 2x squared plus 7. And notice that we have two monomials actually being added together. A trinomial would be something like x to the third minus 10x plus 1. And notice that we have 1, 2, 3 monomials being combined with adding or subtracting. And all of these are called, the sort of general term for these is polynomial. Even the monomial, which only has one little cluster, is a type of a polynomial. Okay, we can talk about the degree of a polynomial. And in the degree of the polynomial, we're going to add up all of the exponents. So, for example, if I'm looking at 5x, since that x would have a 1 on it, that degree would be 1. If I'm looking at 2x squared, the degree of that would be 2. If I'm looking at x to the third, the degree of that would be 3. We're going to do some examples of this in just a minute. If I want to talk about the degree, of a monomial, I'm just going to figure out what all the exponents are added together. If I'm talking about the degree of a polynomial, I have to figure out all of the different parts of it and then list which one is most. So this is example 1. I want you to list the examples by number in your notes so that I can just tell what you are writing about. In this example, we are identifying polynomials. So we're just going to write down 4y minus 5xz. And we're going to say, is this a polynomial? Yes, it's a polynomial. It is the sum or difference of two monomials. There's one part, two parts. What is its degree? Well, what we do is we go through and we add up the exponents. So there's always a 1 if there's not an exponent. So 4y, the degree of 4y is 1, but the degree of 5xz is 2. And so overall, we're going to say that the degree of this polynomial is 2. So see how we had to figure out each piece. A special name for this polynomial, since there are two parts, is binomial. All right, next example in this little list is negative 6.5. Is this a polynomial? Yes, it is. Any number is a polynomial. It's a constant, right, because it doesn't have any variables, but it is still a polynomial. The degree of this, because there are no variables with exponents, is 0. And since there is only one little grouping, we are going to say that this is a monomial. You can draw lines between these examples if you want. I didn't give them numbers. Here's another example, 7 a to the negative 3 plus 9b. Is this a polynomial? No, it actually is not a polynomial. So we are not going to have negative exponents in our polynomials. This would cause this to be, this part of it would be 7 over a to the third, and we're not going to have any fractions with variables and exponents in them. Let's see, so there's no degree and no special name. This is just not a polynomial. All right, the next little example is this, 6x to the third plus 4x plus x plus 3. Is this a polynomial? Yes, it is. And it happens to be simplifiable. 4x and x can be combined, so this would actually be 6x to the third plus 5x plus 3. So this is actually the sum of 1, 2, 3 monomials. We call that a trinomial. And if I want to figure out the degree, we can see that the degree here is 3. The degree here is 1. And the degree here is 0. So looking at the degrees of each piece, the greatest degree is 3. So we're going to call this a third degree polynomial, and specifically a third degree trinomial. All right, 2 more things. Sometimes we want to talk about standard form. And whenever we're putting polynomials in standard form, we just want to put them in a very nice order where it starts with the highest exponent and goes to the lowest exponent in order. So, for example, let's call this example 2. Make sure you number that for me. I have 3x squared plus 4x to the 5th minus 7x. And it says to put this in standard form. And so we are going to rearrange this and put the 4x to the 5th first, and then the 3x squared, and then the minus 7x. So see how I've put it in order of the exponents. And now we could identify a couple things. So the leading coefficient, here's a word for you, leading coefficient, just means the starting number. So the leading coefficient of this one is going to be 3. Oh, sorry, nope. We have to put it in order first. It used to look like it was 3, but truly the leading coefficient of this is 4, because we have to put that x to the 5th first. And the degree of this trinomial would be 5. All right, one more example there. 5y minus 9 minus 2y to the 4th minus 6y to the 3rd. We're just going to arrange this. Watch out for negatives. They stay with their number. Minus 6y to the 3rd plus 5y minus 9. None of that was combinable. And so I could answer a few questions here. What is the leading coefficient? Is -2. The degree of this is 4, because that's the highest exponent, and it is a polynomial. Yeah, and once we have more than 3 terms, we usually just call it a polynomial. All right, let's move on to example 3. Example 3 wants us to add some polynomials together. So we're going to find the sum. We have 2x squared plus 5x minus 7 plus 3 minus 4x squared plus 6x. So the parentheses in this case do not mean multiplication. Notice that there's adding in between these parentheses. And so all we're going to do is add the things that match each other. Watch out for the signs that are in front of the numbers. You can always change them. Add the opposite, that's plus a negative 7. Add the opposite, that's plus a negative 4. In this case now, everything is adding, and I can just combine like terms. So I'm looking for things that match. 2x squared and negative 4x squared can be put together. That becomes negative 2x squared. And then 5x and 6x can go together, plus that would be 11x. And then we have a negative 7 here and a 3, so we're going to go minus 4. And so my combined polynomial would be negative 2x squared plus 11x minus 4. Leading coefficient is negative 2. It is a trinomial, and it is degree 2. All right, let's move to example 4. Example 4 wants us to find the difference. So we have this polynomial 3 minus 2x plus 2x squared. And then we have a minus sign between some parentheses. And this is something that often people get in trouble with, and they make mistakes. Watch what happens with this minus on the outside of parentheses. This is extremely powerful. I am going to change this to a plus, but in doing that, it changes everything inside the parentheses to the opposite. So a minus on the outside of parentheses changes everything inside the parentheses. So that used to be a positive 4x, now it's negative. That used to be a negative 5, now it's positive. That used to be a positive 3x squared, and now it's negative. The other one I'm looking at right here, plus a negative. Now I've changed everything to plus. So all I have to do is carefully combine the like terms, right? I kind of start with the highest exponent. So here's a 2x squared and a negative 3x squared. So that's going to give me a negative 1x squared, all right? Then I'm going to look at this negative 2x and this negative 4x. So I have a negative 6x, and then, color do we want here? I have a 3 and a 5, so plus 8. So combining those, I get negative x squared minus 6x plus 8. And so be extremely careful about minus on the outside of parentheses. In fact, I'm going to do one more example of that just because that is so powerful. 7p plus 4p to the third minus 8 minus 3p squared plus 2 minus 9p. Be extremely careful, be meticulous, write things down, whatever you need to do to keep track of all these minuses. It's so easy to mess them up. All right, here's this minus on the outside of parentheses. I need to change it to plus, but don't just change it to plus. You can't just do that. When I change this to plus, what it does is it goes inside the parentheses and it changes every single sign. So if it's already subtraction, it becomes plus. If it's not subtraction, it becomes a negative. I'm going to just go over here to this -8 and make it plus a negative. And so I have changed everything to plus. Now I'm just going to very carefully combine my like terms. First thing I'm going to look at here is 4p to the third. And there are no other p to the third, so I'm just going to put 4p to the third first. There we go. The next thing I want to look at is, how about p squared? So I have -3p squared, but that's the only one there is, so -3p squared. And then, how about straight up 7p and 9p, so plus 16p. And finishing this up with a -8 and a -2 is -10. So I have 4p to the third minus 3p squared plus 16p minus 10. Leading coefficient is 4. The degree is 3. And we'll just call this a polynomial because it has more than 3 terms. All right. I am going to keep moving here. And I am moving into lesson 8.2. And we're going to just keep working with polynomials. So I'm going to call this example 5 today instead of starting over with 1. So example 5 is -3x squared times 7x squared minus x plus 4. Now, I don't have, let's see, let's look here. This doesn't have anything between the -3x squared and the parentheses. That means multiplication. So in order to multiply, I have to use the distributive property because I have a whole lot of stuff going on here in the parentheses that can't be combined. So I'm going to have to use the distributive property to multiply. I'm going to be taking -3x squared times each piece of what's in the parentheses. I had a student once called that watering the garden. So make sure you water the whole garden and not just the very first part of it. And we're going to be doing this. -3x squared times 7x squared. -3 times 7 is -21. And then x squared times x squared, remember your exponent rules, will be x to the 4th. Next step, we're going to move here and do -3x squared times -x. Negative times negative is positive. That's going to be -3 times -1, so positive 1. And then we have x squared times x. Remembering our exponent rules, that's x to the 3rd because we're going to add the exponents, 2 plus 1. Right, the next little piece here is -3x squared times 4, and -3 times positive 4 is -12, and there's nothing else there, so that just becomes x squared. X squared doesn't have any other x's attached to the 4 to multiply. So I have -21 x to the 4th plus x to the 3rd minus 12x squared. Leading coefficient is -21. This is a 4th degree trinomial. All right, this is example 6. Keep numbering with me, that way everybody's notes will look the same. All right, here's a messy problem for you. 2p times -4p squared plus 5p. And then we have the dreaded minus 5 times 2p squared plus 20. All right, we need to get rid of all those parentheses, so we're going to be using the distributive property. Watch out for negatives. Since we have -5 here, we can do this, plus a negative, and then we can use the distributive property again to multiply each piece. So 2p times -4p squared gives me -8, because 2 times -4 is -8, and p times p squared is going to give me p to the third. This is why we did the exponent rules in the last chapter. And then in the next step, we're going to go 2p times 5p. 2 times 5 is 10. P times p is p squared. So remember, we're adding the exponents there. All right, we're done with that one. So we're going to keep going. Plus, -5 times 2p squared is -10p squared. Okay, if there's not a p with the -5, we just keep that p squared the way it is. And then -5 times 20 is -100. So, we can write this like this: -8 p to the third plus 10p squared. We could write minus 10p squared instead of plus a -10, and minus 100. Those mean the same thing. Leading coefficient is -8. This is a third degree polynomial. And yeah, that one's good. Let's do an equation with polynomials on both sides. So we'll call this example 7. And it says to solve this, so it's kind of long, so I'll try to get it to all fit here. 2a times 5a minus 2 plus 3a times 2a plus 6 plus 8 equals a times 4a plus 1 and plus 2a. I'm going to run out of room. 2a times 6a minus 4 plus 50. Wow, that's a lot. Okay, what we have to do first is to just start undoing these parentheses. We need to simplify this a lot. So let's do 2a times 5a is 10a squared. 2a times -2 is -4a. And then we have plus 3a times 2a is 6a squared. 3a times 6 is plus 18a, and then we'll just keep the plus 8 equals, okay, a times 4a is 4a squared. A times 1 is a, plus 2a times 6a is 12a squared. 2a times -4 is minus 8a. And then we'll keep the plus 50. I almost got it on one line. All right, now I need to combine anything that can be combined. 10a squared can combine with 6a squared. So let's call that 16a squared. And then -4a can combine with 18a. I'm only working on one side of the equals at a time. So I'm not trying to subtract things or I need to keep the different sides separate for now. Okay, -4a and 18a is plus 14a. And then I have plus 8. Let's see, I already used that color. So, okay, so let's say equals 4a squared plus 12a. We'll put those guys together, 16a squared. And then here's an a and a -8a. Remember, there's always a 1 in front of a variable. So this would be minus 7a. And then let's just keep the plus 50. All right, we have simplified both sides of the equation now. So here's our equal sign. So we didn't cross over that at all, but we're now ready to do some solving. So let's try to get things to combine. I want all the a squareds together, I want all the a's together, and I want all the numbers together. And so what's going to happen here now is that I can subtract 16a squared from both sides. It just happens to be what's on both sides. So when I subtract it here, it cancels to 0. And when I subtract it here, it cancels to 0. So that just kind of went away. And then the next thing I'm going to do is maybe add 7a. So see how it was minus 7a? If I go plus 7a, that will cancel. But I have to do that on both sides, plus 7a. And so I'm actually going to do this math here. 14a plus 7a is 21a. And then let's go ahead and bring down this plus 8 equals, and what's left on the other side is a 50. I kind of did 2 steps because that minus 16a squared just did so much canceling. I kind of did 2 steps before I simplified it all up. So now let's subtract 8 from both sides, working on either side of equals. I have 21a, this cancels, equals 42. And then I'm ready to divide by 21. That'll cancel this just like that. Divide by 21, and I get a equals 2 because 21 goes into 42 2 times. And we were actually able to solve that just like that. How do we check that? We would plug this 2 back into that original equation and see what happens. See if it comes out true and equal on both sides. So that is a whole bunch of examples for you. In fact, exactly 7 examples. And I'm going to let you go ahead and do some practice in Alex. I'm not going to assign a specific homework assignment. I want you to just get started working because your initial chapter 8 problems are going to jump you right into working on these things. So we can work on them together and see what questions come up.